IGCSE Computer Science Syllabus Statement 1.3.7a, show understanding of the need for both high-level and low-level languages. So, this is quite an interesting topic. It's the last topic of the last part of topic 3. And we have a programming paper, which is paper 2. But the theory paper, what it can do is ask you some questions that have to do with programming. Now, in paper 1, you don't have to program, but you do have to identify different programming languages. Well, I mean, not languages, but like whether it's higher level, low level, and then you, of course, explain the benefits, and yeah. This is more of a theory of languages than the actual languages, like paper 2 has. So, first question, what is a program? A computer program is a list of instructions to perform a certain task, such as program that prints your name, or program that counts to 10. A program can be written in a high-level language, such as Python or Java, although Java's not really a high-level language. It's like, it's somewhere in the middle, but it's higher than like C, or a low-level language, such as machine code or an assembly language. But modernly, we use high-level languages to program, and you're about to see why. So with high-level languages, the programmer only needs to know the language itself, so there's no knowledge of the hardware and instruction set of the computer required. So this is of course a benefit, because as we shall see, high-level programs can be sent to other computers, or like other people, and then they can use them. They're more universal. Like they work on they can work usually on most computers. So benefits of programming in higher level languages, or higher. I wonder if you're saying higher level, high level. I don't think it really makes a difference. High, low level. Anyway, it's easier to read and understand because the language is closer to the human language. The thing is, like most programming languages are in English, because most of us speak English. Like English is like the language. But what could happen is, like if another language happens to become more popular, such as Chinese, then we could see programming languages in Chinese. That would be, yeah. Just think about that. Less time taken to write them, because again, we like if we know the language, we can see, like we know what to write. It's also easier to debug or find errors, and this, again, same reason. We could read it and we could see, oh yeah, this is where the error lies because this is this. And also, if an IDE, which stands for Integrated Development Environment, if it's used, then what the IDE can do is help you find the errors. So it'll highlight or underline wherever the error lies, and then you can correct it. It's also portable, so as said, write once, run anywhere. So you can run it all, yeah. I was like, okay, so here's Python code for printing hello world. Here's a Java code for printing hello world. So as you can see, like these words we know. We know what a class is. We know what the word public means. We know what the word static means. These are all English words. So like with practice, like it's really easy to learn a higher level language compared to a low level language. Speaking of which, low level languages have to do with the specific architecture and hardware of a particular type of computer. So, but the benefits of programming and LLLs, because like I mean, you'll see when we see LLL codes that it's pretty hard. But it can be used to make use of special hardware. Can be used to make use of special machine-dependent instructions. It doesn't take up as much space in primary memory. And when we get onto translators, you'll see why it doesn't take up as much space. And also the code runs more quickly, and again, you'll see why in the next video when we look at translators. So this is an assembly language, so as you can see, I mean, we can recognize these words like mov, so move, int, integer, and so on. But like it's in a format where we're just like, what in the hell is AH? Like, what is the DX? What is, like, what is this? These things right here, by the way, are comments. So what users can do is add comments to their programs, and so that they understand what goes on in each line. But more on that in paper 2. And machine code is just like, when we talked about assembly languages and machine code in the first topic. So, like, if you want to learn more about like that, then you can go ahead and watch that video. So that's pretty much it for this video, but bonus, hello world in other languages. So you see if you can identify whether these are high level and low level. Most of these are going to be like middle, high-ish languages, I think. I can't remember what okay, Visual Basic, and some of these you might program in now. Pascal, well, I mean, it's basic, but I don't really like Pascal because it's a bit like C. So you can see kind of why. Oh, get the pun. C. You can see why it's no, nothing. Okay, you can kind of see why it's sort of a middle level language. Like, some stuff doesn't really make sense, but C++ is it's its predecessor. It's C sharp, which is quite a bit like Java actually. Ruby. Ruby is a high level language. I don't know Ruby, but I might learn it because apparently it's getting quite popular. Or maybe not, I don't know. And Malbolge, which is just like, whoa, dude. Like, what is this? So yeah, you could research some of these languages, see where they originate from, see what purpose they're, because like basically a programming language is created to solve a given problem, well, you have to solve a problem. So you can go ahead and research all these weird languages and see why this was created. IGCSE Computer Science Syllabus Statement 1.3.7b, show understanding of the need for translators. So, what is a translator? Well, a translator is a program which translates another program written by the user into a computer understandable format, or machine code. So we'll look at 3 types of translators. We'll look at compilers, interpreters, and assemblers. Now, the point of a translator is, if you write a program, say in Python, and you ask the computer to read it, or try to process it, or do whatever, well, the computer can't really understand all that text that you wrote. It's going to have to be like put in a format which the computer can understand and then run. So this is what translators do. So a compiler translates a program written in a high-level language into machine code. When a program is compiled, the machine code can be executed again and again without having to recompile it. So features of compilers: they translate a whole high-level language program to machine code in one go. They produce an executable file of machine code, which you can then run. One high-level language statement can be translated into several machine code instructions. Once a program is compiled, there is no need for recompilation. And the executable file that can be produced is usually distributed for general use. Yeah, interpreters. So an interpreter executes a program written in a high-level language one line at a time. It reads a statement, performs the action specified, and moves on to the next statement. Another one. Features of interpreters. They execute a high-level language program one statement at a time, unlike compilers, which compile the entire thing in one go. No executable file is produced. One high-level language statement may need several machine code instructions to be executed. Interpreted programs can't be used without the interpreter, and an interpreter is usually used in program development. So if you're developing Python apps, for example, so like Python uses an interpreter, then you can use one in program development, so you can like run certain lines in the develop. So the thing with interpreters, because they execute one line at a time, it makes it a bit slower than compilers. So they may run a bit slower. Assembler is the last one. So an assembler translates a program written in an assembly language into machine code. When a program is assembled, the machine code can be executed again and again without having to reassemble it. So it's kind of like a compiler, but with low-level language. Features of assemblers. Translates a low-level language program into machine code. Produces an executable file of machine code. One low-level language statement is usually translated into one machine code instruction. Once a program is assembled, there's no need for reassembly. So instead of compilation, it's assembly. And an assembled program is usually distributed for general use, just like compiled programs or executable programs in compilers.